Actually, we have our primary task is to find out the resultant of any given force system. First, let us take up to determine the resultant of a coplanar concurrent force system. So this we are going to do it by method of resolution. So we already have studied what is this method of resolution. So resolution is nothing but splitting a given force into its x and y components or any other directions also. But we have seen that it is convenient to resolve a given force into its x and y components. So after having resolved this, how to take it forward to find out the resultant of coplanar concurrent force system. That is what we are going to see now here. Now let us first of all represent one coplanar concurrent force system by considering x-axis and y-axis. So the origin itself, I will take it as the point of application of all the forces here. So I have a force F1 making an angle for F1, F2, F3, which are forming a coplanar concurrent force system. So the magnitudes of all these forces definitely should be given, but we also should know the angles made by the forces with the x directions. So even if the angle with the y direction is given, we can immediately calculate the complementary angle, and that we can call as the angles made by the forces with the x direction. So in this case, theta 1 is the angle made by the force F1 with the x axis. Similarly, the other angles F2, F3, F4. So these are the primary requirements. So all these should be known to us: F1 theta 1, F2 theta 2, F3 theta 3. Even if the angles made by the forces with the y are given, please immediately calculate the complementary angles and get ready like this. Then we can next think of resolving each force like F1, F2, F3 in a number of given forces to x and y components. So I will call this, and now we have to get the resultant R. In this case, this is just a representation. The resultant R is nothing but the resultant of all the given forces F1, F2 and F3, and this is our job. So determining the resultant means we should also calculate the magnitude and direction. The direction means the angle made by the resultant with the x-axis again has to be measured, which I call it as alpha. So our job is to get R and alpha. So this is the general case. So let us know the procedure as to what to be done, and then we can see here. So F1, F2, F3 and F4 represent a coplanar concurrent force system, and our requirement is to find out the resultant. So and all R and alpha are our requirements. So let us do, what should we first do? Let us first resolve each force into its component forces in x and y directions. X and y direction. So what am I going to do? First I will resolve all the forces into its x components, add all the x components algebraically. Next, then let me consider the resolved components along y directions. Again I will add them algebraically to get the sum of component forces in x and y direction. Let us elaborate here. So if let me consider this force F1, which is making angle theta 1 with the x axis. So when I resolve this, I will call fx1, small fx1, as the x component of this force. So that fx1 is nothing but f1 cos theta 1, and fx2 is nothing but the x component of the force F2, which is nothing but F2 cos theta 2, and Fx3 is nothing but the x component of this force F3, which is nothing but F3 cos theta 3, and Fx4 is nothing but the x component of the force F4, which is nothing but F4 cos theta 4. So this is the procedure. Similarly, the y components we call them as Fy1, Fy2, Fy3, Fy4 and Fy4. Now the sum of component force in the x direction. Now if you see here, we can resolve F1 into its x component, which will be to the right here, which is nothing but F1 cos theta 1. Similarly, the x component of F2 is nothing but F2 Fx2, which is nothing but F2 cos theta 2. Fx3 is nothing but F3 cos theta 3. Fx4 is nothing but F4 cos theta 4. Few x components are acting to the right and a few x components act to the left, but we have to add them algebraically. That means we have to follow a sign convention. Any horizontal force acting to the right will be assigned positive value. Any horizontal force acting to the left will be assigned negative value. So we can add them algebraically to get this one. So This is nothing but sigma fx, fx1 plus fx2 plus fx3. Similarly, we can get the sum of all the y components in the y direction as sigma fy here. So sigma fy is nothing but fy1 fy2 sub plus fy3 plus fy4. Fy1 is nothing but the y component of f1, which is nothing but f1 sine theta 1. Fy2 is nothing but f2 sine theta 2. Fy3 is nothing but f3 sine theta 3. Fy4 is nothing but f4 sine theta 4. But if you see the vertical components or y components, the y component of f1 is acting upward, y component of f2 is acting downward, y component of f3 also acts downward, y component of f4 acts upward. Again here, any force acting vertically upward, I call it as positive, and any vertically downward force, I call it as negative. So with this sign convention, now if you see, all vertical forces can be added together to get one single force in y direction. We already have seen all the x components can be added to get one single force in the y direction. So now that means 4 forces are now reduced to only 2 forces, which are nothing but sigma fx and sigma fy. Now these sigma fx and sigma fy represent single forces along x and y directions. Now since we have only 2 forces, to get the resultant we can use parallelogram law to get the resultant of sigma fx and sigma fy, which is nothing but the resultant of all the 4 forces. So what I need to do is I have to again apply parallelogram law for this case. So that means sigma fx represents one single force in the x direction, and sigma fy represents the single force in the y direction. To get the resultant of these two, I can construct a parallelogram with these adjacent sides, and now the diagonal through the same point is nothing but the resultant, making an angle alpha. So to get the value of alpha, we have to use the general using the equation for parallelogram law. Here now r is nothing but sigma fx square plus sigma fy square, and alpha is nothing but tan inverse of sigma fy by sigma fx. So this is the general procedure.